do it that way. There we are. That looks a lot better. So I was one of the founding team members at Agari. We've been around for about 5 years. I have helped a little bit in the fight against cybercrime. One thing that I did is I helped Microsoft and the FBI with the B-54 Citadel botnet takedown. If we get some time, I can maybe share a little more about that at the end. I have worked at large and small companies, so I started my career at Oracle, went on to SAP, doing like application stuff, and then I branched off, went to make my internet millions, and have been CTO of a number of startups. And currently at Agari, I am our field chief technology officer. It's kind of like Santa has elves. I'm sort of the CTO's elf, and I come out and speak at conferences and such. A little bit about Agari. Agari's mission in life is to eliminate email as a vector for cybercrime. And yeah, exactly. Hey, it's good to have a big goal, right? And you know, if we even get close to that goal, I think we'll actually be pretty darn happy. We've got quite a few clients that you've probably all heard of because we help people stop phishing of their brand. Well, obviously the brands that get phished tend to be companies that you have heard of. So you know, 4 of the top 5 U.S. banks, 3 of the top 5 banks in the UK, and 4 of the top 5 social networks use Agari to protect their email stream between them and their customers. So, all right, today I'm going to cover, first of all, why do cyber criminals love email? Probably everyone in this room already knows the answer to that. I'll tell you about a few previous attempts to solve the whole email spoofing, email fraud problem. And then we'll talk about what I believe is the current best solution, which is a combination of SPF, DKIM, and Dmarc. We're going to get into the technical details of those, and then I'm going to show you some open source tools that you can use. If you guys want to go and try to implement these things yourself, you don't have to pay money to a company like Agari. There are tools out there. You can roll your own, basically, and not spend a dime. We'll talk a little bit about some edge cases and a few things that Dmarc doesn't necessarily play well with, and some potential solutions there. And then we're going to do something fun. We're going to take a data breach, specifically the most salacious data breach of last year, the Ashley Madison data breach, and we're going to use that data to estimate Dmarc coverage by country. So that should be a little bit interesting. And then finally, if we have some time at the end, I've got some additional fraud examples that I'll share because some of them are a little bit entertaining. So the whole reason we're here goes back to 1982. So SMTP was sort of first rolled out in 1982, and the inventors, they did such a great job. We're still using the protocol today, but they forgot one very important thing, and that was authentication. Basically, I can connect to a mail server and say, hey, I am, in this case, security at wellsfargo.com, and I have an urgent message for you. And you can imagine if I was actually a cyber criminal, I would lead people off to a fake Wells Fargo login page, capture their username and password, and then go in there and move some money. So what do criminals do with this flaw? Well, here's an example, a somewhat more benign example, unless you actually go and try to buy these products. Basically, this is what I call pharma spam. So I'm sure everyone in this room has received at least one offering to sell you usually Viagra, Cialis, various other medications without a prescription. And the problem is, if you actually do go and click that link and go to this website, this is not really the Canadian healthcare mall. These are usually operated out of, you know, countries that are, how shall we say, don't have extradition treaties with the U.S. The pills they will sell you may or may not have the active ingredient in them. I guarantee you they're not genuine Pfizer pills. They are knockoffs. So good luck to you if you go and order some of those. You might get very ill from them. Here's another example, phishing, extremely common. I had a really good PayPal example, and my guy over at PayPal said, please don't use our example. And I'm like, really? Come on. Everybody knows you guys get phished all the time. He's like, no, we don't want to highlight that. So okay, fine. So I used an Apple example. And this is actually a pretty poor example. I've seen much better ones, but you know, here you can see well, it's a last notice here. We're going to suspend your account if you don't click this link and give us your credentials, because somehow, of course, giving my username and password is going to let them keep my account open. If you click the link, you end up over at this lovely little website, which looks pretty darn genuine, except to the technology people in the room who might actually check that address bar and note that not only is the little green padlock missing, it doesn't bear any resemblance, shape, or form to Apple. And then finally, again, a very poorly done example, because all my really well done examples, the folks didn't want me to show them to you today. But this is an example of malware. Again, this one's horrible. It just says invoice, and then the attachment name is called augmentingmommy.zip. I think if they'd spent maybe just 5 more minutes fine-tuning this, they would have had a little bit better response rate. But if we take that over to VirusTotal, we find out that yes, indeed, 43 out of 55 of the scanners they run over there determined that it was some sort of nasty stuff, basically a keylogger. All right, so that's what the bad guys are out doing. I didn't even talk about the most common thing we're seeing lately, which is the business email compromise. This is when they send your finance team an email supposedly from the CEO saying, hey, I got to wire $3 million to China, and we have to do it immediately, and I want you to keep it hush-hush. And you might all chuckle. Mattel lost $3.2 million. Ubiquity Networks lost $46 million. They later got about 6 of it back. And there was one other big one, I forget the name of it, that was, made all the headlines, that lost like another 10 or 15 million. So yeah, it's out there. In fact, was it you? No. Yeah. Yeah, it's everybody gets these emails, and sadly, once in a while, somebody falls for them, and it's horrible because the money's wired away, and typically the banks aren't going to reimburse you when there's a certain degree of carelessness and stupidity involved. So, previous attempts to fix this. So, one of the first things that people tried was this idea of sender policy framework. In concept, very, very simple. In practice, fraught with issues. But the idea is, there's my mail server. Its IP address is 1.2.3.4. That's where all my mail comes from. I'm going to publish a record in my DNS, and I'm going to tell everybody, if you get a message from my domain, it better come from that IP address. There's problems with that we'll get into in a moment. Not to be outdone, Microsoft said, hey, if SPF is cool, we're going to come up with this thing called Sender ID. It's going to be just like SPF, only better. It did finally die a rather inglorious death. They finally have agreed to sort of stop using Sender ID. But basically, Sender ID offered the additional capability of not just authenticating the RFC 821 envelope, but actually could authenticate the RFC 822 from header, which seems like a great idea. The problem is nobody wanted to go and do that, and the reason is you could not render a decision during the SMTP transaction before you accepted the entire message. So that was really the benefit of SPF, was the fact that you could verify it right at the beginnings of that SMTP conversation. You didn't have to get down into the full message content. Then there was domain keys. This was something that Yahoo did, and it was the idea of a digital signature applied to a message. And then Cisco sort of joined forces with them and fine-tuned it and came up with domain keys identified mail. Pretty much the same thing, just a few minor differences that made it slightly more secure, and DKIM is by far the more widely accepted and adopted standard today. Then we had author domain signing practices, ADSP. The idea here was, how is a receiver supposed to know if you sign your mail or not, right? Because DKIM's optional. You don't have to do it. And so the idea behind ADSP was, if I sign all my mail, I'll publish a little record in DNS that says, I sign all my mail. So, if you get a message that's not signed, you probably ought to just drop it because, it's not really from me. In practice, nobody really implemented it. It just, it was a little baby step that nobody really embraced. This next one's near and dear to me, the idea of visual trust indicators. So my last company before Agari was a company called Brand Mail Solutions. And we were in competition with Iconics and Goodmail. Anybody ever hear of any of those companies? Yeah. So the idea behind all of them was that you would have some kind of email authentication, and then if the message checked out, you would actually flag it in some visual way as being authentic. And here's an example from the old Brand Mail homepage showing you a typical mailbox where everything looks the same. And then you have a branded mailbox where this particular message from Quinn Direct is clearly identified as being authentic. And then if you hover over that little envelope, you would get some additional detail. Brandmail and Iconics did it based on open standards. Goodmail did it based on a proprietary technology. Basically, all the companies are gone now, except Iconics is amazingly still in business. In fact, we sold our IP, our patents, et cetera, to Iconics a couple of years ago from Brandmail. So the And then finally we had the famous PayPal experiment of 2007. So PayPal was a pretty early adopter of domain keys and SPF, and so as they looked at their list of users, the vast majority of them got their mail at Yahoo, at least 50% of them. So they figured, well, a lot of this phishing problem could go away if we just got Yahoo to check the SPF and domain keys, and if they didn't pass, block the message. Don't even stick it in the spam folder, just kill it outright, and maybe provide a little information back to PayPal, so just in case something goes wrong, PayPal is aware that something's gone wrong. And amazingly, it worked. When they put this in, it stopped the ability of criminals to spoof PayPal.com to Yahoo inboxes overnight. But there's a problem, and that is that it's great. It solves it for PayPal, and it solves it for specifically PayPal users at Yahoo. It doesn't do anything for the Gmail users or the AOL users who also use PayPal, and it certainly doesn't do anything for JP Morgan Chase or Bank of America users who get their mail at Yahoo. And so right about that time, there were some rumblings, and by the time we got to about 2009, the rumblings got pretty loud, and we started actually discussing how could we take that experiment and make it scale to the internet, okay? And what we came up with was Dmarc. I'm not even going to, well, I'll give it one shot here. Domain-based message authentication, reporting, and conformance. Should have seen me the first week that came out. I would bungle it every single time. I've gotten a little better with it. Anyway, so we're going to talk about Dmarc a little bit today because in my view, that is the one that's got the best legs, at least at the moment, has the greatest chance of solving this problem. In case any of you are interested in the standards, there are some of the standards, and of course the slides are available online, I believe, later today or whenever, so you will have access to that, the list of the standards if you want to really give yourself something to help fall asleep by. In terms of how this all works, you've got SMTP at the bottom, right? That's moving the mail around the internet, no authentication. Then you've got SPF, that's like basically your list of IP addresses that say, this is where my mail comes from. And then you've got DKIM, which is a digital signature applied by the mail server that can be validated at the receiving end. Big problems, though, with SPF and DKIM. The biggest problem is most people don't know where all their mail comes from. You remember when I said, like, oh, my mail comes from that server right there? Yeah, that's what all the techies think. Ask your marketing department where your mail comes from. Probably comes from a place like ExactTarget or Constant Contact, Vertical Response, or any one of about 1,000 other companies that provide marketing services. Ask your HR team how they do recruiting. Oh, I bet you they have some company out there, maybe Taleo, which is now owned by Oracle, sending out mail saying, hey, come work at company X. We've got great jobs. Simply put, if you don't know what that email landscape looks like, you're going to bungle your SPF, so that's not going to work. And of course, if you don't go and give these guys a key to sign with and set that, the public part in your DNS, you're not going to be able to use DKIM either with those folks. So the big challenge here was how do you figure out where all your mail is coming from so that you get your SPF and DKIM right? As long as SPF and DKIM are working, this system is brilliant. But if they're not working, your real mail is going to go missing. So what we came up with was Dmarc. And the idea was, first and foremost, give the domain owner a way to figure out where all their mail is coming from. Tell them where it's passing SPF, where it's failing, where the stuff is being DKIM signed, where it's not. And also, as a side effect, figure out where all the criminal email is coming from. And then once somebody uses that data and cleans up their SPF and DKIM and gets it working really well, give them a way to do like PayPal did and said, hey, from now on, I don't want you accepting mail that fails the standards. And so Dmarc was born basically January of 2012 with a rather small announcement from Google, Yahoo, AOL, and Microsoft, who all said, we support this standard. And actually, they'd been supporting it for several weeks prior to the announcement, and we had already gotten most of the kinks worked out. So let's go a step deeper here. So first of all, hopefully this is all review, but this is SMTP. Basically, you telnet to port 25 on the recipient's mail server, which, by the way, you can look up by looking up the MX host in DNS. And essentially, when you connect, the server says something like, here's my name, and I'm ready. And then as a client, you say hello, and you give your name. Then the server says something along the lines of 250. Codes that start with a 2 is like a success code. 4s are sort of temporary errors. 3s are kind of just informational, and then 5s are actually errors. So it says, okay, fine. And then I say, hey, I've got a message from test@test.com. and then they're typically going to say, hey, the sender's okay. And then I'm going to say, and I have a message for, in this case, my personal Yahoo account. Maybe I shouldn't have shown that to this room. Please don't start spamming me. Anyway, and then recipient's fine, and then we say data. And then typically they say, go ahead, and then is the message. Now, notice down here we have a from header. We're going to get into this a little more in a second. But this is the difference between the RFC 821 envelope sender and the RFC 822 from header. Finally, you end with a dot on a line by itself. They say OK, or in some cases not, as you will see, and then you say quit, and now I have handed the message off to Yahoo, and presumably Yahoo is going to go deliver it. All right, let's talk a little bit about identity. So here is sort of just the client side of that conversation. We have several different identities in here. We have the hello domain. We have the envelope domain. We have the signing domain if there was a DKIM signature. And finally, we have the from header domain. Now, in some cases, those are all going to be the same, and that's going to be fantastic. Everything is very, very clear. However, in some cases, they are not the same, and we run into a situation where we have what's known as an identifier misalignment, and that's something we'll need to address with the Dmarc standard. All right, here's a couple of SPF records. I love Apple's SPF records. The advantages of having a Class A network with all 16 million or however many, maybe even more than that, a lot of IP addresses, all starting with the octet 17. And interestingly enough, they're telling the world that's the only place we send mail from. So apparently Apple does not use any, at least for Apple.com, does not use any third-party services. PayPal has a much more complicated setup. They actually have all these little mini includes, and those includes have other includes, and eventually they resolve down to lists of IP addresses. All right, let's look at some typical mail flows. Okay, in the simplest world, you know, you've got your postfix server and you send to a Gmail user. That green host is going to be in your SPF record. Maybe you've got Exchange on premise, and then you're sending to Office 365, and they're actually sending it out to the final recipient. In this case, you would list the Office 365 server in your SPF record because it's the last hop. That's what the internet sees as your mail coming from. And then, what's that? Yes, exactly. And then finally, you have other situations, what I call relays or forwarders. Your SendMail server sends to some address at UCLA, but it turns out that that person already graduated, and they have a little pointer set up at their email address, and it's going to bounce it over to, say, Yahoo. Well, unfortunately, you know, whoever the sender of this is going to list that SendMail server in their SPF record. They don't know anything about that UCLA server, so when Yahoo sees the message, that message is not going to pass SPF because we've introduced an extra hop. This is why we use two standards, why we don't just rely on SPF. So SPF breaks due to relaying or auto-forwarding. Mailing lists are a huge problem for SPF, and that's going to be one of my edge cases we talk about in a moment. It authenticates the envelope domain, which is, you know, the mail from. You and I don't typically see that when we get an email message. We're looking at the from header. So authenticating something I never see isn't probably the wisest thing in the world. SPF has this interesting little quirk. It was designed to prevent SPF as being used for to commit a DDoS attack, and that is that you have to have a maximum of 10 DNS lookups required to fully parse your record. So as you have all these different includes, and they, you know, kind of keep chaining or whatever, the idea is that after 10 lookups, the receiver is just going to throw its hands up in the air and say, give up. Yes? It doesn't include the root one, so technically you get 11 total. Basically A tags, MX tags, PTR tags, what's the other one? Includes and redirects each eat one. An IP4 or an IPv6 tag does not eat any lookup. And there are a couple of tools out there that you can use online that will actually tell you. They'll analyze the record and say, oh, your record has 9 lookups. Your record has 11 lookups. And then finally, a lot of people forget about a special case. You guys ever go on vacation? You ever set up one of those vacation messages? I'm out of the office until January 12th. Until January 25th. I'm at the Scale Linux conference. Those are out-of-office messages. Another similar situation, I'm sure everyone here has gotten one. You fat finger an email address and you get a bounce back, a non-delivery report. Well, it turns out the envelope domain in both of those situations is empty. It's null. So what the heck are you going to do the SPF check against? Well, the specification says we are going to check the hello name in those instances. Well, you got to make sure that you put an SPF record in for those hello names for each mail server that you have, or non-delivery reports and out-of-office messages are not going to pass. And it looks something like this. You put one of these in for each of your A, which means this host name, and a minus all. So in other words, any IP address that that maps to that name will be acceptable. All right, switching gears a little bit, domain keys identified mail, DKIM. This is the other standard. Now this one's kind of neat because it will survive that forwarding typically. As long as nobody tampers with the message in transit, we don't care if it takes the short route or goes through 1,000 servers on the way to its destination. So here's an example. This is actually added as a header in the email message, and there's some interesting pieces here. If we look here, this is the key lookup, if you will. So Yahoo would look up this key if it received a message like the one up there with that header in it to validate the signature. And so the way they get the key is they take the selector, or the S equals tag, and then they take the D equals, or the signing domain, then they stick them together with underscore domain key in between, and they do a DNS text lookup, and the result, they get this key, which is in base64 format. That key can then be used to validate the signature. There's some other interesting parts of the signature. If you look here, I can show you. Here you can see where it says H equals date, from, to, subject, et cetera, et cetera. Those are the headers that are signed. Little helpful hint, do not sign headers that are likely to change. Signing the received header, maybe not the best idea in the world, because those kind of typically get changed and added along the way. But that's a pretty good set right there. You also don't want to not sign a header that's fairly important. If you don't sign the subject header, somebody can take that message, change the subject, and still have the signature validate. So you have to exercise a little caution there when you're deciding what to sign, what not to sign. All right, there are a few issues with DKIM. If DKIM was perfect, we would just say, well, don't use SPF, just use DKIM, right? First of all, there's such a thing as what I would call benign message modifications. Anybody ever run a mail server that like to take the from and the to addresses and put them in a very specific format? Because you can have the friendly part in double quotes, or you can just have it without the double quotes, and then you put the real address in angle brackets. There's a few different ways you can do it. Well, some mail servers have a certain way they prefer to see it, and they will rewrite those addresses to fit what they believe is their preferred pattern. Well, that's basically a benign modification, but it is a modification nonetheless that will break the DKIM signature. Most notably, we discovered Cornell University does this with all their alumni. So if you are a Cornell alum and you are finding you are not getting your Facebook, LinkedIn, or Twitter notifications, this is probably why, because they like to rewrite that. Again, mailing lists typically break DKIM. Now, they don't have to, but the main reason they typically break is because mailing lists like to mark up the subject line. They usually like to put the list name and angle brackets at the beginning, or square brackets at the beginning, is a fairly common thing. They also often like to put a little footer at the bottom. Hey, this was sent to you by the such and such list. To unsubscribe, click here, that kind of thing. Those are message modifications. So if you send a signed message to a, say the Southern California Linux distribution list, when that gets remailed, that signature is probably not going to be valid anymore. Also, DKIM validates that signing identity. It does not necessarily validate the from header. I could sign your message. Doesn't mean your message is any more or less authentic, right? All we can say is that we know I signed it. So the best situation is, of course, when the signer and the from header are one and the same, because then we know that the signer actually did author the message as well. DKIM does have the potential for a replay attack. So now there are things to mitigate this. There's an expiration. You can put a special tag in the DKIM signatures. You can say, hey, the signature expires in 15, 20, 30 minutes, whatever, some reasonably short period of time. Now, the only thing somebody could do if they replayed this would be to just basically take a signed message that was sent by a legitimate entity and then send it to, a billion of their closest friends. It might create some headache for the person who originally wrote the message because people would feel they were being spammed. But it's not like you can go and change the message and make it more useful to the attacker. It just means that you would have to replay that precise identical message. And then finally, with the advent of cloud computing and more importantly cheap cloud computing, it turns out you can kind of basically you can factor these keys. It turns out if you have a little bit of money and a little bit of patience, and so and also DKIM keys are typically quite long-lived. They, you publish them in your DNS. I've seen companies that are still using the same keys, after 5 years. I recommend that, 6 months to a year, you might want to consider rotating them. In any case, Google will not accept a key smaller than 1,024 bits. So if you sign something with a smaller key, send that message to Google. They will just say, oh, it was signed with too small of a key. We're going to pretend it wasn't signed. So that's their solution to it. My recommendation, at least use 1024. If possible, use 2048 bits in your key. All right. So on to the final standard here, Dmarc. So once again, we're going to overload that DNS system, make it really work its earn its keep here. They're stored as DNS text resources, and they're stored at _Dmarc, so the special location, and they have a very special format. I've just looked the one up for Twitter, and it basically says they're using version 1 of the specification. Their policy is they would like receivers to reject messages which cannot be proven to originate from Twitter. They would like aggregate and forensic data sent to those 2 addresses you see there, which happen to be my company because, like I said, we process the Dmarc data for many companies that want to get the business value out of it, but don't necessarily want to spend many hours coding and putting together open source solutions and such. And then finally, there's this option, the FO tag, which is the failure options tag. The domain owner would like forensic reports for any messages that have failed either SPF or DKIM. In other words, one or more protocols. You could also set that to FO equals 0, meaning you want only the things that have failed. Yeah, I believe that means that only the things that have passed no standards. You can also say S or D, saying I only want to know about the DKIM failures, or I only want to know about the SPF failures. Little hint here, notice the format of the RUA and the RUF tags. There's this little mail to : in front of the email address. The idea there was that eventually there might be other mechanisms to transmit the data. Today it's sent via email. Don't forget the mail to. Your record probably won't work if you forget that, and it's a very common error. All right, let's talk a little bit about subdomains, right? So not everybody sends from twitter.com. Sometimes they send from news.twitter.com or alerts.twitter.com, and actually subdomaining can be a really neat thing. It helps you divide your mail streams out. It helps you get around things like SPF record lookup limits. Suppose you have 6 different vendors that are doing various things on behalf of your company. Well, you give them each a different subdomain, and then their SPF record only has to include their hosts. You're not going to run into that lookup limit. But as far as Dmarc is concerned, Dmarc records are inherited by subdomains automatically. So this is fairly important to note. So if you put your top level at reject and you didn't realize that there were a bunch of subdomains in use, you might have just stopped their mail flowing. So not a good thing. However, there is an SP tag that you can specify which will say, this is my top level policy, but for every subdomain I want the default to be this other policy. So you can use the SP tag. And then finally, subdomains can have their own records which override the higher level record. And here I've done a couple of examples. If we had dmarc.example.com at reject with an SP of quarantine, foo.example.com with a policy of none, which basically means monitor only, don't take any special action, and a subdomain policy of reject, and finally bob.example.com with a policy of reject, we get the following little matrix. So top level obviously is reject. bar.example.com is quarantine because there's no specific record overriding it, and the top level record says SP equals quarantine. So that would apply. Similarly, foo.example.com has P equals none. It has its own record. It overrides. billy.bob.example.com is going to be reject because it's going to take the bob.example.com. There's no SP tag, so it's going to use the P tag. And then finally, john.foo.example.com will be reject because of the sp equals reject on the record for foo.example.com. Yes?
So how do you reject on the full domain? So for example, I would have a developer that would create, example1.example.com, example2.example.com, and do I have to create a record for all of them, or can I
Nope.
say by default?
Nope, by default. So at the top level, if your top level is reject, then all of those will be reject by default. If you want the top level, say, to be monitor, but everything else to be reject, you can say p equals none, sp equals reject. And that means all subdomains are going to be at reject. So yeah, infinite flexibility, basically. All right. One other little gotcha with Dmarc. Let's suppose you want to send your data to another domain. Boy, what a great way to spam somebody, right? Publish a Dmarc record, and I take your email address and I say, hey, send all my Dmarc data to him. Probably he's going to get annoyed pretty quickly. So, the folks that thought of this particular challenge. And so, if you want to send your Dmarc data, you can send it to your own domain, no problem whatsoever. However, if you wanted to send it to somebody else's domain, there's one extra little step. So you need to get the domain that's going to receive your Dmarc data to publish a very special DNS text record where it's basically your domain ._report._Dmarc .their domain. And then all they do is they say v equals Dmarc1. If that record is present, then Google, Yahoo, etc. will say, yeah, okay, they're willing to accept data for domain X. I'll give you a little hint. Google, by the way, will not, how are you going to send your Dmarc data to your Gmail account? Well, you're not, unless you're Google, because you could send it for gmail.com. However, Yahoo has a nice little wild card in there, and they will happily accept Dmarc data for anybody. So if you've got nowhere to send your Dmarc data, set up a free account on Yahoo and send it there. I just did a dig there for any random domain.org, ._report, etc., and lo and behold, they do in fact return the all-important v equals Dmarc1. All right, so let's suppose you publish a Dmarc record. What's going to happen? Well, at the address you specified in your RUA tag, you're going to start getting some data. It's typically going to happen, usually happens about 5:30, 6 p.m., because that's when UTC, time zone switches over to the next day. They all of these guys, run their MapReduce or their, Hadoop or whatever, crunch through piles of data. I can't even imagine, for somebody like a Google or a Yahoo, to basically go look at the last 24 hours of data or mail that's come in and prepare all of these reports. But what they're going to do, they're going to email you a zipped XML file. And that, actually a gzipped XML file. And that XML file is going to look something like this. There's going to be a header part. And the header is going to basically have certain tags. This particular thing is being reported by Yahoo. If we wanted to, ask somebody about this report, well, we'd ask postmaster@dmarc.yahoo.com, and they've given us a report ID that we could presumably refer to. Those are supposed to be unique, though in practice I've occasionally seen collisions there as well. Then we have the date range that this refers to. Those are just Unix timestamps, and the astute among you will realize this example is a little bit old. I probably pulled it several years ago, but it basically refers to a 24-hour period. It's very typical that people report on a 24-hour boundary. And it's specifically for the domain alertsp.chase.com. It's some kind of alerting that JP Morgan Chase does. I forgot to talk about alignment options. So remember, we've got all those different identities, right? We've got SPF checking the envelope identity. We've got DKIM checking the signing identity, and then Dmarc's all focused on the from identity. Well, the Dmarc standard says if I'm going to use the DKIM signature, then the signing identity must be aligned with the from header. Same thing with SPF. If I'm going to do that, the envelope has to be aligned with the from header. Now, there are two flavors of alignment, strict and relaxed. Strict has to be an exact match. If it's foo.bar.com here, it's got to be foo.bar.com here. Relaxed, you can have parent-child or even sibling domains. So you could have, bar1.foo.com, and you could have bar2.foo.com. They will both roll up to foo.com. And yes, they do take into account things like .co.uk, so they know that that's actually sort of one step there. So in any case, this record is saying that Chase's Dmarc record for alertsp.chase.com specifies a DKIM alignment of relaxed and an SPF alignment of relaxed. If that was an S, it would be a strict alignment. This literally comes straight out of the original policy. So in other words, if you queried for the Dmarc record, basically Yahoo's just playing back saying, this is the Dmarc record we found for you. And their policy is to reject mail. You also see the PCT percent. They would like that applied to 100% of the mail. Now you might be like, why on earth would you not want to apply it to 100% of the mail? Turns out that when you're first turning this stuff on, some people, especially at large corporations, get a little nervous and they want to ramp it up. So they may say, you know what, start off, just block 1% of the failures. Choose them at random. And then start blocking 2% of the failures and eventually get it up to 100%. I personally think if the data is telling you it's clean, go to 100%. But, you know, I don't work for a bank or any other highly regulated industry that would, you know, fire me instantly for doing something like that. So after this header, you then are going to get a whole pile of these. Individual records. You gotta love XML, the way they can take a tiny little bit of data and make it take up this much space. But anyway, thank goodness that now you know why they're gzipped. This particular record says that source IP 106.10.149.115 sent one message. It passed DKIM, it failed SPF, and no special action was taken against it because, of course, it passed DKIM. It's an either or, by the way. You don't have to pass SPF and DKIM. You have to pass one or the other and be aligned. Then they're telling us the from header was alertsp.chase.com. The DKIM domain was alertsp.chase.com, and the result was a pass. The SPF, unfortunately, failed. Now, does anybody, what can you tell me about this particular record? DKIM passed, SPF failed. Remember that diagram I showed you where we go through UCLA on our way to our final destination? This is one of those situations. DKIM survived, but that host 106.10.149.115 does not belong to JP Morgan Chase. It probably belongs to some university, some mailing list, something, some relay. By the way, I've seen these files get as big as 600 megabytes after they're decompressed. So, you know, if there's they get big. Sorry, wait, did I say, yeah, 600 megabytes, almost a gig. Just all it takes is, you know, one good botnet attack and can blow your file up in a hurry. Now, there's another type of Dmarc data. Not everybody participates. Specifically, Microsoft participates. Yahoo sort of participates. Yahoo will give you forensic data if you work with Agari or one other competitor where we have a private relationship with them. And the main reason they won't send forensic data to just anyone, they're afraid of, in the event of an attack, your mail server will be overrun with them sending forensics. But forensics are basically copies of the messages that have failed one or more of the protocols. Here's an example of one. They are sent in ARF, abuse reporting format. If any of you are familiar with that, it's basically a way you encapsulate an RFC 822 message inside of a MIME type that's carried along. So this is the header, basically the thing giving us a little bit of information, and then there's the actual attachment, which my Mac mail client here actually displayed inline, but that actually is a separate, RFC 822 MIME type. We're going to get into that a little more in a minute because that really lets us do some nifty things to sort of take a stab back at the criminals. So this is what happens every single day now at Yahoo, Gmail, Comcast, people who are running Ironport, Symantec, and a bunch of other places. I'll walk you through this. So a message comes in out of the internet, and the real question they're asking is, do SPF or DKIM prove the message came from the domain on the from header? Yes or no? Then, is the content okay, so assuming it passes, notice we are not skipping the spam check. Just because something can be proven to come from who it claims to come from, it could still be spam. So yes, you could still end up in the spam folder. However, if SPF and DKIM don't prove the message was sent by that entity, we go to the second side over here. We look up the Dmarc policy. And if it is none, we just send it over here, run it through the spam filter, business as usual. We are going to report about it, of course. If it's quarantine, we send it to the spam folder, and if it is reject, we send it to the trash. There also are the concept, there's the concept of local policy overrides. That is something where the receiver can, at their option, say, we know better and we're going to ignore the policy. We cringe when we see that at Agari because we watch them let fraud in and we're like, why did you do that to your users? The bank tried to tell you, and yet you let it through, and they're doing it less and less, but there is the option to do a local policy override. So let's look at this in action. Here's a nice little session of me telnetting to port 25 over to Yahoo. This time, instead of pretending to be Wells Fargo, who is just starting to do Dmarc, I pretended to be security at chase.com, who have a very mature Dmarc implementation. And you'll notice instead of that nice 250 OK at the bottom, we get an error code, 554, message not accepted for policy reasons. In other words, it's actually rejected in line during the SMTP conversation. In other words, you'll get a bounce back. If you're a human user and something went wrong, you're going to get a bounce back, and it's going to tell you that it failed because of Dmarc, and then you're going to go talk to your email admin, and you're going to say, okay, why did my message fail Dmarc? All right, a couple of limitations. So Dmarc does not do anything to solve the friendly from problem. What is the friendly from problem? Well, as you all know, there's the email address and then there's the display name. And these mail clients, they try to be so nice to dumb it down for all of us, and instead they've made us all a lot less safe. Here's an example, chasecard182 at hotmail.com. I bet you it might even pass authentication. So one thing that might help here is the idea of inbox differentiation. So my now defunct company, BrandMail, is no longer around to do this. However, Google was running a little experiment we call the Google Gold Key. It's in a Google lab right now, where they'll actually put a little key icon next to messages that they've checked the authentication on it. So this might be a way forward. Not a guarantee. Only works at Google and only if you have the lab. But main point being, you still want to check that email address. Don't just look and, if it's your CEO's name or your bank's name, don't assume that the email address is really what it says it is. Also, if you're running your own mail server, like Hillary Clinton tried to do there for a little while the State Department, you're not going to be protected by this unless you go and install some of this open source stuff we're going to talk about in a moment. However, more and more places are implementing Dmarc, so the pool is shrinking. And there's also a certain sense of herd immunity. What we've noted is that when a big consumer domain publishes a reject policy, we usually see the criminals kind of go away and move on and pick a different brand. If you can only hit 10% of the bank's users now, and you got to guess who they are, it's probably easier to just go find a bank that hasn't locked the doors yet. So there's some benefit there. All right. A couple years ago, Yahoo.com, in other words, the domain that all of you get if you get a free Yahoo account, published a P equals reject policy. And this did a couple of things. First and foremost, all the folks that basically had no idea how to go get their own email address and had simply been using their Yahoo mail address to run their flower shop or their plumbing supply company or, insert small mom and pop business here, they all suddenly found that their thing they were running with Constant Contact was no longer working because, of course, Yahoo didn't authorize that. They only authorized the Yahoo mail servers. The other thing that happened was a lot of folks who ran mailing lists started to scream very loudly, Yahoo, you have broken my mailing list. What did they mean by that? Well, it turns out mailing lists don't work super well with Dmarc for two reasons. Number one, there's that extra hop. So SPF, forget it. It's not going to work. And mailing lists like to modify stuff. They like to change the subject line. They like to put a footer on the message. So DKIM is out the door. But here's kind of the gotcha. So let's suppose now somebody who's been on this mailing list for the last 10 years, they have a yahoo.com address, they decide to post today in the post-reject world. That goes to the mailing list server, and the mailing list server goes and sends it to all 12,000 people on the list. And a lot of those people get their mail at Gmail, Hotmail, AOL, or other places that do Dmarc. However, the message failed Dmarc. They're going to bounce it back. But wait, it gets worse. Most mailing lists have a little feature in there that, hey, if you try to send to a user 3 times and it bounces 3 times, stop sending to that user forever. So guess what happened? As soon as about 3 or 4 people from Yahoo posted on any given mailing list, everybody who was on Gmail, Hotmail, Yahoo, et cetera, got unsubscribed automatically from the list. So this is what they meant when they said Yahoo broke my mailing list. Well, Yahoo didn't break the mailing list. Yahoo is trying to protect people from fake Yahoo messages, and in doing so, forgot a very important edge case that was a pretty big deal for Yahoo.com. Not such a big deal for most companies. Okay, I bet you most of the people in this room, because you're all kind of engineering types, probably do participate in a lot of mailing lists. We are, kind of not the normal folks, if you will. But for the average business user, mailing lists really aren't that big of a deal. What are some options, though, to deal with it? Well, you can put the onus on the list participant. So you can say, hey, list participant, don't use a yahoo.com. Go get a gmail.com address. They don't do p=reject yet. Or go, pick some other domain. Use, if your company has gone to reject, ask them to create a subdomain that they leave at p=none, so that your mailing list traffic won't have this problem. Now, the big problem with that, the advantage, of course, is you don't have to change the mailing list software at all or anything else. You just change the address you're going to use. The downside is, okay, so you switch to Gmail. I guarantee you Gmail is going to do this at some point too. And if you use a subdomain of your corporate domain, then your company is left a gaping hole that the criminals could take advantage of. We could put the onus on the list operator, right? Instead of doing what they normally do, send the messages from the list itself. So Yahoo user emails the list, but now when it goes out to everybody, instead of the from header saying the original guy from Yahoo, move him to the reply to, and then use the list's email address in the from header. And that actually works pretty well, and it keeps the mail flowing. However, it does change the semantics of reply versus reply all. I guess mailing list users are used to when you hit reply, it's going to just go back to the list, is it, or vice versa? Anyway, the point being that by shifting those around, some people were complaining that reply and reply all basically now inverted their use. The other, also, you got to get the list operator on board. And the list operator may or may not be willing to adjust something that they see as not created by them, fixing a problem there. Not all mailing list software, has an option even to do this. The good news is that one of the most common ones, Mailman, does. And there is a link right there where they literally tell you exactly how to set it up, which patch you need, et cetera, et cetera. So if you guys operate a mailing list server and you want to keep your Yahoo and AOL users happy, you might want to have a peek at that. It's a pretty straightforward thing. You can also put the onus on the list operator and basically do the status quo, but just don't unsubscribe people for Dmarc failures. At least you won't, now the guy at Yahoo won't be able to post anymore, but at least he won't unsubscribe everybody at Gmail and AOL in doing so. And then finally, the receiver could detect that this is mailing list traffic, and they could override the policy. And this is actually what Google does in a lot of cases. However, this is dangerous because now a spammer can use that mailing list as a way to send a fake PayPal message, for example, get the list basically to deliver it, knowing that the policy will be overridden. So I don't think that's really a great solution. The one that seems the most promising at the moment, but is way too new, the jury is still out, is a new thing called Authenticated Received Chain, or ARC. Google has basically said, look, this is what we're going to do to fix Google Groups for this particular problem. We're going to implement it internally, and by the way, we're going to put the specification out there, so if anybody else who runs a mailing list wants to do this, you have the option. It basically involves a couple of extra headers that are added. They're digitally signed, and then every time this goes through another hop, somebody can basically re-sign the thing and say that, oh, yes, indeed, I checked the authentication, and I'm passing it along. And basically, it gives a way that by the time it arrives at Google, assuming they trust the people that have said they checked the authentication, they'll at least know that the thing originally passed authentication. Anyway, you can read more about it on arc-spec.org. All right, how are we doing on time? Got about 10 minutes left. All right, I got to get moving here. All right, open source tools. OpenDKIM. You can go download it. What's it do for you? Well, it's a C library, so if you want to just kind of play with signatures, you can code against that library and do some nifty things, kind of play around with it. But it also comes as a milter, which is a mail filter. It'll work with SendMail, of course, and also with XIM, and with a little extra shim layer in there, you can make it work with QMail. Basically, it will sign for you. It will also verify for you if you want it to do that. Yeah, I believe it will. Postfix. Yeah, I believe it will. I'm 90% certain. We'd have to check. So, okay, open source SPF tools. There's, yes. Oh yeah, absolutely. Exactly. Here's how you set it up. I will be honest. You're going to spend the better part of an afternoon reading the documentation and so on and so forth. However, at least, based on what I've shown you today, you'll have an idea in your head as to what it's supposed to do. I mean, that's kind of half the challenge with some of these packages in the first place. I am also going to point you to a really good URL. I've got a little resources section at the end. There's a guy that literally walks you through the whole steps of getting this thing set up and working, and he's done a huge service to the community by doing that. There's a pile of tools available for SPF. This libSPF2. There's various packages. You can do it in Python, Java, even .NET if you wanted to. There's various options there. And interestingly enough, Dmarc, which is the thing that will actually do the Dmarc verification. So if you want to protect your users from fake PayPal messages, fake Chase messages, fake Bank of America messages, the way you do that is you're going to load this Dmarc thing. You're going to run this on your mail server. Once again, it's a milter, it's a mail filter, and it actually has SPF checking built into it. Or you can set a flag and you can use the SPF library from the other thing if you were already using that. So it can either generate its own SPF results or use the results from the other package. It does, however, rely on DKIM. So you will, at a minimum, need DKIM to do the DKIM check. All right, those are the tools. I'm going to give you guys links at the end, so including that awesome link that's going to literally just walk you through, here's how you set it up, and it's going to hopefully make everybody's life a lot easier. Let's talk about adoption. So based on sort of what the community, dmarc.org, has said, these are the folks that are supporting it today, and a rough count of how many mailboxes they have. So Yahoo supports it, and they white label the mail for AT&T, Rogers, and a few other places. Google supports it, including, this is old, there's about 6 million Google Apps domains now. So all those folks that use Google for their email infrastructure, that is included in that coverage. Microsoft is Hotmail, Live.com, Outlook.com, MSN, and they're just starting to get their feet wet with Office 365, so their business users are getting it as well. AOL, Comcast, NetEase is a big Chinese ISP. QQ in China, by the way, even bigger than NetEase, just started sending reports a couple of months ago. So that's an exciting one. And then some other smaller outfits, Mail.ru, Yandex, etc. Based on that, we estimate, U.S. coverage of a typical consumer list at about 85%. Worldwide, a typical consumer list at about 60%. There are also things for business users. Yes, question? Yep. Yes, Apple is definitely working on getting iCloud and Mac.com, Me.com, getting those squared away. They sent us some test files several months back, and we tested them, and they were close. And we sent them back with a few little, hey, you got to adjust this, and this isn't quite working right. They've gone quiet on us, but I know they are working on it. I wish I could give you an exact date. The last word I have from them is they are absolutely committed to it. They already do it on the sending side, of course, and they are implementing it on the receiving side. So a little more patience, and they will get there. Are you a Apple iCloud user, or just? Oh, of course. Yep. Yeah, exactly. Okay, then on the business side, so for open source, yeah, SendMail, Postfix, and QMail. You can use the Dmarc milter. With QMail, you need this QSMTPD, which is some other little shim layer that's going to let it work with the milter interface. On the commercial side, of course, there's Google Apps, Cisco IronPort, Proofpoint, Symantec Cloud, Message Systems. Again, they use that milter. Message Systems, I think, is changing their name to SparkPost, if any of you are familiar with them. Office 365. However, Office 365 will, the most they'll do is they'll quarantine. If you have a reject policy, they will back it off to quarantine. They're not quite confident enough that there's not a lot of mailing list users and other edge cases. And Alt-N, M. Demon out of, I think, Irving, Texas, outfit down there. If you guys know, I think his name is Arvel. Great guy down there, runs another mail server, and they are supported as well. All right. However, you know, it's one thing to say that 80%, 90%, whatever, of U.S. consumers get their mail at a place that, you know, supports Dmarc. However, your mileage may vary. And what a lot of people want to do is they want to say, hey, what's my coverage? If I implement this, how many of my users will be protected? So I'm not going to do it if half my users are protected, but I'll do it if 90% of them are. So we start with a representative list of email addresses. You know, for most companies, you have your list that you email on a regular basis. We can look up the MX host. We can see if that host is known to support Dmarc by basically looking at that list of, you know, Google Apps. You know, any Google Apps domain lists the same, you know, set of MX hosts. Same thing for Yahoo. Same thing for Outlook. You know, Outlook.com. And then you tally everything up at the end, and you'll have your percentage coverage. So I wanted to do that. I went through that exercise. The problem is, you know, I don't have a consumer list. My company, we sell to businesses. So I use the Ashley Madison breach data. So so for those of you who don't know, Ashley Madison is a site where married people can make new friends. And there were some hacktivists who how shall we say, did not really like their business model, and they said, we have your list of users and all their personal details, including all their communications with other users, their credit card details, etc., and we will release that unless you pay us X millions of dollars and shut your site down. Well, Avid Life Media, the parent company of Ashley Madison, said, no, that's not going to happen, and sure enough, right on target, out went the list. So anyway, in the brief amount of time it was available on the dark web, I got my hands on it, and I went and ran these. And so I, you know, obviously a lot of the addresses were gmail.com addresses. So I did the lookup, and yep, google.com, check. Netflix.com. Yeah, actually, if there were any Netflix users on there, they use Google Apps. Yep, check. UCLA.edu. No, they run their own mail server. What's that? Yeah. There were, yes, there were military addresses on there. There were quite a few from most of the major corporations that all of you know and love. There were also quite a few that were clearly fake. So there were a lot of profiles that actually used either avidlifemedia.com or ashleymadison.com as the actual email address, like a very inordinate number of them. In other words, they were obviously chumming the waters a little bit, trying to make it look a little closer to 50-50 when in fact it was about 98 to 2% in reality. Anyway, tallying it all up, drum roll please, amazingly, Venezuela, at least amongst Venezuelan Ashley Madison users, has an incredible level of Dmarc coverage. Almost all of them, 96.9% get their mail somewhere that does Dmarc checking. The good old USA, 90.7%. Now, you know, this might be slanted slightly because I suspect a lot of the users of Ashley Madison probably set up a free email account just for that purpose, and most of the common free webmail providers obviously are supported. Anyway, you can see the numbers there. Most notably, though, and this really confirmed what we already suspected to be true, Germany and Japan had really the lowest coverage. And there's a good reason for this. Germany and Japan both, you know, they have their own technologies to do these things. They have their own webmail providers. In Germany, it's United Internet, so it's web.de, 1&1, and GMX. In Japan, it's Yahoo Japan, which is actually SoftBank and is not at all part of Yahoo, despite the name, as well as NTT. So we are, at Agari, we are evangelizing this, and we're hoping to get the German and Japanese markets up to 80-90% coverage so that their users can be protected as well. Yes. Exactly. So spewing out diesel hydrocarbons anyway. All right. So we are at the bottom of the hour. I don't know if there's an immediate intervening session. I'm basically done. I did have a couple of additional fraud examples if anyone wants to stick around for a moment or two. This one was kind of interesting. I was on my way to a meeting with Western Union, and we saw in our data this sort of interesting spike of mail coming out of a .mil server, an Army .mil server, sending out a bunch of Western Union mail. And we thought, that's a little odd. Why would the Army be sending out Western Union email? And then we had a look at the subject lines that the Army was sending out. Oh, did that not? There we go. And final notice, $7,600 US daily payment for you. Obviously some kind of a spam campaign when we see this many. It's not just A/B testing. They were doing A, B, C, D, E, F testing of their spam campaign. In any case, our CEO happened to have a buddy who did the mail for the Army. Called them up and said, oh, yeah, thanks, another one. They said, yeah, every once in a while we get a contractor on our network who's got malware installed, and it starts using our server to send out a bunch of spam. Anyway, I feel safe at night. Okay. We had Twitter had an amazing amount of phishing. I mean, I never would have thought of Twitter as a place like that you would want to get somebody's Twitter credentials, because I've got about 160 followers, so I don't know what you would do with my credentials. But apparently folks like the AP or CNN, they have a lot of followers, so I guess those accounts are kind of valuable. Anyway, Twitter found that there were as many as 100 million phishing messages going out every single day. So we worked with them, we got them locked down, put them to reject, and literally 2 days after they went to reject, the criminals figured out this was not working anymore, and they just gave up. It's been flatlined ever since. Now, that's kind of a cool result, but the really cool result is that Twitter was able to take several dozen people that had been pulled from their day jobs to go and do account resets because of all the people that were getting phished, and they were able to send them back to revenue-generating jobs. So, you know, to me, that's a pretty big result, that it actually did impact the bottom line. All right, last example. Or is the next session like immediately starting, or no? We got a couple. Okay, so this last one actually was a friend of mine. He had sold a camera on eBay, and then he gets this email, and you know, I'll read it to you. It's the print's a little small. It is my pleasure to inform you that I have carried out the payment of $4,800 via PayPal. I just got a receipt from PayPal, so if you haven't, please check your spam now. I am sure you must have been notified also. I want to send it to my elder brother for work. I would have asked you to send it to my eBay address, but I'm currently on a business trip to Kansas. Here is the delivery address. And of course, it is in Nigeria. Yes, okay. Anyway, and then he says, you know, hey, I really want you to ship this today. I gave you an extra $100 to cover the quick shipping and all, and you know, please gift wrap it carefully. Anyway, the key point is you can see what was happening here. Obviously, this person thought they could just send a spoofed PayPal message. Maybe it was going to end up in spam, hence the check your spam folder, thinking that this person would just read that and say, oh, okay, I got my money, I'll send it on. Like, never mind, they're not going to actually check the PayPal account. Anyway, the point is that, you know, a non-savvy user, someone who's, you know, hasn't had 5,000 of these conversations with me, might have just simply sent the money on had they gotten that email. But because of Dmarc, they didn't get that message. So save somebody some money. Anyway, that's it. Thank you all so much. And where did that go? There we go. Yeah, first of all, I'd like to get that 160 followers up to maybe 200 by the end of the year if possible. So by all means, feel free to follow me on Twitter. It's JMWSecure. I mostly tweet about cybersecurity stuff. So you're not going to, if you want my political leanings and all that other stuff, that's my private account and whatever, but this is all business. And then here's some very key links. And again, it's in the presentation that's going to be uploaded and available online. Great. Thank you all.